Now, how do we go about actually trying to find out what the original functions were if we're given a particular differential equation? Let's take a look at this. If we have dy dx is equal to x over y, and we're given an initial condition y equals -2, one technique that we're going to use in order to solve this particular differential equation is what's called separation of variables. And the separation of variables problem usually follows 4 steps, which we'll see. Step 1, we're going to want to separate our variables. Go figure. In this way, we want to make sure that all of our y's and dy's are on one side, and all of our dx's and x's and variants of those are all on the same side. Oftentimes, you'll find it easy to cross multiply, like we did right here, and that'll separate your variables, and maybe it'll take another step beyond that to figure it out. In this case, all we needed to do was cross multiply, and we get y dy is equal to x dx. Step 2, integrate each part as if you're dealing with just a single variable on each side, which you are. In this case, we've got the integral of y dy equal to the integral of x dx. When we integrate y, we get y squared over 2. And when we integrate x, we get x squared over 2 plus c. We only need to use 1 plus c, even though we get 1 on both sides, technically. We only need to consider just one constant because combining the 2 constants on both sides will leave us with just one super constant. Step 3. We want to figure out what c is. Since we have an initial condition, we can actually figure out what c is, since we know that x and y values. In this case, we know x is equal to 1 and y is equal to -2. So in plugging both of those into our equation, we can figure out that -2 squared over 2 is equal to 1 squared over 2 plus c. Working this out, we find out that c is equal to 3/2. Step 4, we want to actually solve for y. Now we can plug in c since we know what that is, and we get y squared over 2 is equal to x squared over 2 plus 3/2. Multiplying everything by 2, we get y squared is equal to x squared plus 3. And technically, if you were to solve this normally, you would get that y is equal to plus or minus the square root of x squared plus 3. But we want our particular solution to actually be a function. And so we need to think about whether or not we want the positive branch or the negative branch of this square root. In this case, we go back to our initial condition, which was that y of 1 is equal to -2. Since y of 1 is negative, we need negative solutions to come out of our function. And so we will take the negative branch. You can always check your work by plugging in x is equal to 1 and finding out that y, according to this, has to be equal to negative the square root of -2. You can also check your work by going through and taking the derivative. In this case, we get that dy dx is equal to -2x over 2 square root of x squared plus 3, with the 2x coming from the chain rule, the inside part of the square root. We notice that -2x, the 2 cancels out with the top and the bottom. And so we get a -x over square root of x squared plus 3. Now, one thing to notice is that we said y was equal to negative square root of x squared plus 3. So now we can rewrite this as we did in class the other day as dy dx equals -x over y. Positive x over y. It's positive x because y was negative to begin with.